In this video, we're going to look at another example on how to solve absolute value equation. And what's special about this example is that you see why sometimes we have to reject some of the solutions. The absolute value function is often denoted as f of x is equal to x with x written in between the two vertical lines. The way we define the absolute value function is that if x is positive, then it is simply just equal to x itself. However, if this x is negative, then we're going to define it as the negative x, and this is going to convert it into a positive value, so that essentially the absolute value function always gives us an output that is always positive. In other words, it gives us the magnitude but without the direction or the positive and the negative signs. Using the definition of the absolute value function, we're now going to look at how to solve this absolute value equation. Absolute of x minus 2 is equal to 2x minus 1. The absolute of x minus 2 has got two possibilities. It can be either positive, in which case we're going to define it just as x minus 2. If x minus 2 is negative, then the absolute of that is going to be defined as the negative of x minus 2. In the case where it is positive, we're going to be considering this equation. X minus 2 is equal to 2x minus 1. So if we solve this equation, first I'm going to add 2 to both sides. This cancels out the negative 2. We get x is equal to 2x plus 1. Then subtracting 2x from both sides in order to make sure that the x is on one side, we have negative x is equal to 1. Then dividing both sides by negative 1, we're going to get our first solution, which is x is equal to negative 1. Now at this stage, x is equal to negative 1 is only a possible solution. So now let's consider the negative possibility. If x minus 2 is negative, we're going to be solving this equation. Negative x plus 2 is equal to 2x minus 1. So starting off by subtracting 2 from both sides, we're going to get negative x is equal to 2x minus 3. We're now going to subtract 2x from both sides. So we have negative 3x is equal to negative 3. Then dividing both sides by negative 3, we're going to get our next solution. X is equal to 1. Again, at this stage, x is equal to 1 is only a possible solution. Once we have got the possible solutions, our next step is to verify those solutions. So starting off with x is equal to negative 1, we're going to sub into this equation. So substituting x is equal to negative 1 into the left-hand side, we're going to get the absolute of negative 1 minus 2, which is equal to the absolute of negative 3, or just 3. If we sub x is equal to negative 1 into the right-hand side, we're going to have 2 times negative 1 minus 1, which is negative 3. And what we see is that the left and the right-hand side are not the same. So this means that x is equal to negative 1 has got to be rejected. Let's now check the other solution, x is equal to 1. Again, using the same set of equation, substituting x is equal to 1 into the left-hand side, we're going to get the absolute of 1 minus 2, which is equal to the absolute of negative 1, which is simply just 1. Substituting x is equal to 1 into the right-hand side, we're going to get 2 times 1 minus 1, which is equal to just 1. And in this case, we have the left-hand side and the right-hand side being the same. So we can conclude that x is equal to 1 is a solution. So why is it that we only have one solution instead of two? Well, when we're solving this absolute value equation, we consider two possibilities. If x minus 2 is positive, we're solving x minus 2 is equal to 2x minus 1. This is solving for the point of intersection of the two graphs, x minus 2 and 2x minus 1. And we see that they intersect here at x is equal to negative 1. But this point is below the x-axis, which actually doesn't exist on the actual absolute value function. When we solve for the negative possibility, we're solving negative x plus 2 is equal to 2x minus 1. And here we're solving for the point of intersection of the two graphs. And here they do intersect at x is equal to 1. And in this case, the point of intersection is above the x-axis. Now, the absolute value function is essentially this V-shaped curve. And you can see that when we look at the point of intersection of this absolute value function and the straight line y is equal to 2x minus 1. In fact, we only have one solution, which comes from here. This solution doesn't exist. Thanks everyone for watching the video. Hope you guys found that useful. For more videos on this topic or other topics, please do check out our channel. We do release videos weekly, so don't forget to subscribe. We hope to see you all in the next one. Bye for now.